The year was 1790, and the deadliest volcanic eruption in what would eventually become a part of the United States was about to occur. This scene did not occur at the infamous Mount Saint Helens or in a remote section of Alaska. Rather, it occurred at a volcano generally known for its mostly effusive eruptions, Kilauea. Several hundred residents were gathered in close proximity to the volcano's caldera rim, which at the time had cooling fragments of lava within it and no lava lake, with the caldera being quite deep and filled in at the bottom with collapsed sections of the caldera wall. However, another eruption was imminent. In the several days beforehand, minor eruptive activity had occurred, some of which ejected now cooling lava as an even larger intrusion of magma made its way underneath Kilauea's summit. Then, this magma began interacting with the area's water table, which was 1,800 feet below its caldera rim top. Due to the heat generated by the magma, much of it was passed on to the above water table, causing large sections of it to flash to steam. Since the same massive steam takes up more volume than the water it once was, it caused an immense amount of pressure to build. Eventually, this pressure became too great and the ground exploded upwards from a depth of more than 1,000 feet, sending large boulders of rock as much as 1.2 miles or 2 kilometers beyond its caldera rim. As a plume of ash shot 30,000 feet or 9 kilometers into the sky, part of the eruption column collapsed downwards, generating devastating pyroclastic flows which incinerated areas up to 3,500 meters or 2.17 miles beyond the caldera rim. While this was occurring, ash was deposited to more than a foot thick in some areas. Most likely, several hundred people lost their lives due to this eruption, which was approximately 1/13 the size of the 1980 eruption of Mount Saint Helens. In total, 0.1 cubic kilometers of tephra was ejected, meaning the eruption was assigned a Volcanic Explosivity Index of a 4, which is hundreds of times more explosive than the average eruption at Kilauea. While modern-day activity at Kilauea is almost completely effusive, producing lava flows within the caldera and occasionally at rift zones away from its summit, we have witnessed recent events which were explosive. The most famous of these occurred in May of 1924 and May of 2018, which through a series of phreatic and phreatomagmatic explosions sent a plume of ash more than a mile into the atmosphere. As, in terms of long-term cycles generally lasting hundreds of years, the Kilauea volcano produces alternating periods of primarily effusive and primarily explosive eruptions. We have been in a primarily effusive phase since 1800, but this might eventually change. It might come as a surprise, but during the last 2,000 years, the Kilauea volcano for slightly more than half of the time was in a dominantly explosive phase, with the last explosive phase ending around 1800. Most of these explosions produced during these explosive phases were not the same size as the aforementioned 1790 eruption, but rather 1 to 3 orders of magnitude smaller. These explosive eruptions were not caused by unusually silica-rich magma, but rather due to the region's water table. You see, at many shield volcanoes around the world, a summit caldera is a common feature, often forming due to large volume flank eruptions away from a volcano's summit. Caldera expansions and collapses are uncommon, but when they do occur, there is a chance that the area lava would fill could drop below the water table top. Thus, if a crater lake forms, this lake is quite likely to be eventually destroyed in an explosive eruption. Or, if a blockage builds up around a magmatic intrusion which is at the level of the water table, the surrounding water will flash to steam and explode, destroying the above blockage. The magic number for this to potentially occur at Kilauea is for a section of the caldera floor to be around 1,800 feet or 550 meters lower than its highest rim. This actually occurred after Kilauea's 2018 eruption, but other than the eruption itself, it surprisingly did not lead to a period of explosive eruptions. As, following 2018, several eruptions quickly filled the lava lake to a depth of above the water table and no major blockages formed. Thus, Kilauea is still currently in a period of mostly effusive eruptions, with explosive eruptions having a low probability of occurring. Thanks for watching. If you would like to request a specific topic, please leave a comment below. Additionally, I would like to thank this channel's patrons on Patreon and channel members on YouTube.